Good morning, everybody. I am Anusha from CSE Department, Institute of Aeronautical Engineering. In this ICT videos, I will be discussing about programming with objects, which will be done in Java. So this programming with objects is basically discussing about Java programming. So let's look into the subject. Okay, so what is the main need of computer programming? Basically, computer language was mainly used for adapting to the changing environments. Like there were a lot of requirements in which computer was brought into use. So when to the adapting changes, we had to use computer languages to give computer to make the computer work. We have to provide some language to it. So and also to bring about improvements in the programming language. So initially, the languages which was in use were Fortran, Basic, assembly languages and all. So they had some issues in their uses. What happened with Fortran was that it was not really very good for system code, and Basic could not be used for large programs, and assembly level languages was not very easy to learn and debug. So then came the programming language C. So C was a structured, efficient and high level language which replaced assembly level coding. And after C came the C++ and Java. So Java is mainly inherited from C and C++. The syntax of Java mainly followed C programming, and the concepts of OOP features was taken from C++. Let's look into the history of Java. Who was the founder of Java? So Java was developed by James Gosling, then Patrick Norton, Chris Rath, Ed Frank, Mike Sheridan, at Sun Microsystems in the year 1991. So these people together, they were working with they were looking out for some platform independent language which could be used on embedded systems also. The programming languages like C, C++ was not able to work with such embedded systems. So because of that, they were looking out for some programming language which can be used in embedded systems, and it should be platform independent. So that was the main motivation for bringing up the programming language Java. Now also this Java was initially called as Oak. Then later it was called as Greentalk, and after which finally it was named as Java in 1995. Now what is the important feature of Java which is making it different from C, C++? The main thing is that the main Java's magic, we can call it as the bytecode. The ability of Java is to the Java bytecode or the Java program can be used to execute, the same program can be used to execute in different operating systems or different platforms. Like the same program can be executed in Windows, in Unix, Mac or in mobile. So that was the main feature of Java. Main feature of Java. The thing is that what happens is Java has something called as the virtual machine, Java virtual machine or the JVM. So this JVM, what it does, it will convert the Java by Java. What happens here as such is, we have the Java source code. Let's say we have the Java source code, say program called as sample. We have the Java compiler. So what will the Java compiler does? It will compile the Java program. Check for errors. We will correct the errors, and then it will again check and convert it into a intermediate code called as bytecode, which is with the dot class extension. So the Java compiler will initially convert the Java program into a bytecode. Now this bytecode can be executed This intermediate bytecode can be executed by various machines. Each machine will have JDK, which is having its JVM installed in it. So these JVM will convert the intermediate bytecode or the dot class file into its corresponding machine code. So this JVM is the one which is responsible for making Java platform independent. So the same bytecode can be the bytecode which we received from Windows can be taken and executed in Unix, Mac, or any other platform. So that is the biggest advantage of Java, the presence of Java virtual machine. The Java virtual machine and bytecode together making Java as a platform independent. Now let's look into JDK, JVM, and JRE. So JDK means it's the Java Development Kit. So this full thing together is forming the JDK. So inside JDK we have the JVM and the JRE and other files which can be used for the execution and compilation of the program. The JRE contains the JVM, and it is the real implementation of JVM. JRE is the implementation of JVM, and it also contains the various libraries which can be used for the Java programming. So the main importance of JVM, which is an abstract machine, Java virtual machine is an abstract machine which does not exist, and it will provide a runtime environment for the bytecode to execute, and it also performs these tasks like loading the code, verifying the code, executing it, and all these functions are performed by the Java virtual machine. Now this Java runtime environment, or the JRE, is the actual implementation of the JVM, which will consist the various libraries and APIs which is required to execute the code. It also contains various software tools and for developing the applications, and this is the one which really exists. But JVM is a abstract machine and it does not physically exist, but JRE will physically exist. Now let's look into the Java features or Java buzzwords. These are the various features of Java which is making it highly usable. The first one is it is object oriented. It is simple to use. It is secure. It is platform independent. It is robust. It is portable. It is architecture neutral. It is dynamic, interpreted, high performant, and multi-threading and distributed. So these are the various features of Java. Let's look into them in detail. Now, why is Java very simple? See, Java was inherited by using the C and C++ syntax and other object-oriented features, because of which the programmers found it very easy to use, very simple to use, because the syntax of Java was more or less similar to the C++ syntax. Then object-oriented. Java is mainly implements object-oriented model which uses classes and objects to implement every program. It is robust. It is robust because it provides a multi-platform environment for web. It is a strictly typed language, means that you have to you have to declare a variable whenever it is being used, and it will check your code at the compiling and the runtime. Then it has better memory management and exception handling because of better memory management, because it has automatic memory deallocation by which is achieved using garbage collection, and that is completely automatic. We as in C++, we don't have to, the programmer don't have to write the code for memory deallocation. In Java, this memory deallocation is completely automatic, and also you can handle runtime errors of your program so that the flow of the program is not interrupted. Next is architectural neutral or portable. This is, as we have discussed, because of the presence of Java bytecode and the Java virtual machine, the device is made, the Java programming, Java is platform independent. The same bytecode can be taken and executed in various devices without any issues. And this also it also uses a just-in-time compiler, because of which it is it performs very well. Now, another feature is multi-threading, wherein it allows the user to do multi programs at the same time. Like, for example, let's say we have a program to read an array. We read the array. After reading the array, we have to sort it, print it, then find max of the array. Like, we have 3-4 events to be done. So if you are using this C, traditional languages like C, what happens is that they are linear. Like, after performing one method, you can go for the other. But in Java, because of the presence of multi-threading, what it does, this sorting and finding max can be given to two different threads. That means a thread means they are smaller process. Okay. So after these sorting and finding max is completed, then they can be taken together and given to another, used for printing the method. So this feature is available in Java. That means you have the ability to use multi-thread. So you have one process. In that process, you can have multi-threads, in which each thread can be used to apply for different functions, which can be used to do other functions, and they all work together. Like, not one after the other, parallelly they will be executing, because of which it speeds up the execution. Now, next feature is the distributed feature, because of which it can be used in networks. Because of the present, it also allows the remote method invocation, which enables the program to work across networks. Then Java is also dynamic, means that you can verify and resolve access to objects at runtime. So everything can be done at runtime, and also it allows the dynamic linking of code, and it may also be dynamically updated on a running system. Now, Java is also an interpreted language, wherein the Java bytecode is interpreted into machine-dependent code. And the use of just-in-time compiler makes it highly performing, and there are various security features which disables the access to certain parts of the program and also the certain parts of the computer. So these were the various features of Java. Now let's look into the two programming paradigms. There are basically two programming paradigms. They are the process-oriented model and the object-oriented model. The process-oriented model is the one which is being used in C, wherein it is considered as a series of linear steps. Okay, and in object-oriented programming, everything is organized as classes and objects. So all the data will be enclosed in a class. All the data and the members, all the members of the program will be enclosed in a class, and it can be. But in process-oriented, they are mainly linear. They are executed in a linear form. The main example are C programming, which follows process-oriented, or C programming, and Java and Smalltalk are object-oriented programming. This process-oriented programming is also called as procedural-oriented programming. Now let's look into the various differences of procedural and object-oriented. Now, in procedural language, they are mainly divided into smaller functions. The program is divided into smaller functions, but in object-oriented, they are divided into objects. Then, in project-oriented, importance is on the sequence of action, but in OOPS, the importance is given to the data rather than the procedures. Okay. Then the POP for the procedural oriented programming follows a top-down approach, whereas OOPS follows a bottom-up approach. Then there are no access specifiers for POP, but they uses access specifier like public, private, protected for the in OOPS. Then for in POP, the data can move within function easily. Within the function, the data can be moved, but in objects in object oriented, they are moved through functions. Then in POP, the data access is easy and they are freely available, but in OOPS, we can provide protection of data using these access specifiers. Then since the data is not hidden, like because there is no use of access specifiers in POP, they are less secure, whereas the data is more secure in OOPS. Then POP doesn't allow overloading of operators or functions, but OOPS allows overloading of functions and operator. But Java doesn't allow operator overloading for the users. The users cannot overload operators as in other programming languages, but it allows function overloading. The examples of POP are C, Fortran, VB, etc. C++, Java, these are all object-oriented programming languages. Now let's dive into object-oriented paradigm. So as we have discussed, object-oriented programming languages will always use classes and objects for its working. Now these are the various features of an object-oriented programming, which uses objects and classes: abstraction, encapsulation, inheritance, and polymorphism. These four forms the OOPS concepts. Okay, they are the OOPS concepts or features. So in any object-oriented program, the software program itself is defined inside a class. So what is a class? A class is a data structure which class is a data structure which contains the member variables or the instance variables. These members can be instance variables and the methods. And the methods are functions. So the class will encapsulate all these members together. And so using this class, we define how the object will behave and what will be the status of the object. So now a program may contain multiple classes. Okay, you can have multiple classes. So because of which it is providing modularity, and these classes can be reused in some other program also. They can be imported. These classes may be imported, and which allows the use of reusability of the code. Next, once we define the class, if we want to operate on it, we have to create an object of it. So object is called as the instance of the class, and it is used to interact with one another. And also it contains the objects uses these methods which is defined in the in that particular class. So say we have a class A. Now once we create an object of class A, this object of class A will have its own variables and its own method, which will be a copy of this class A. Now, if you consider an object, so let's say we take an example of dog. So we have class dog, and the dog, it can bark. That is, it's one of the method. Sleep and say eat. So these are the methods of the class dog, and it has variables like breed, then age and color. Okay, so these forms the variables, and these are the methods. So these are the instance variables of the class dog, and these are the methods of the class dog. So if you take any object of a particular class, that object will have these three features: the identity, the state, and its behavior. The identity of the object means it is the name of that particular object. So let's say for the dog class, let's say we have we name it as AB. Okay, so the name of the dog is AB. Okay, now that dog is of type, say, lab. Okay, so the breed is a lab type, Labrador, and its age is just 2 years, and it is brown in color. So these are the features of that particular object dog. Okay, so that particular object is Abby, and that Abby dog has these features. It is a Labrador dog, and its age is 2 years, and its color is brown. So these are the state or attributes of that particular dog. Now, the various if you take that dog, it can bark, it will sleep, and it can eat. So these forms the behaviors or the methods of that particular dog. Okay, so if from a class we will define an object, and this object is an abstract data type. So if you consider the object AB, you will understand that it is a dog and it can do all these operations. So, but you are unaware of how they are being done. So that is why it is called as an abstract data type, and these object will have these three features: the identity of the object, the state, and the behavior. Now, let's look into the OOPS feature of abstraction. So what is abstraction? It is basically hiding the implementation detail from the user. So let's take an example of a car. So if you consider car has these many features in it, right? Isn't it? But the driver who's using that car need not know about how these things are working. So we just use it. So in the same way, when in Java programming, we will define a class to work in some particular way, but we will be while using that class, we will be using only its abstract data type object. So everything will be working with the object. So when we use that object, we don't have to worry about how that method is being implemented. We don't have to worry about the logic of that code. We don't have to worry about how that method or how that class is being implemented, but we just use that object for our need, according to our need. Right. So that is the main feature of abstraction. So the user don't have to worry about the internal details of that program, but you just have to know about the essential requirements of it. Okay. So it is so if you consider the car is completely hiding all these features from the user. On using all this, we get to drive a car. So that is abstraction. Next feature is encapsulation, wherein it binds the code and the data together. So here also we have this class is encapsulating, or it is bringing together the various data members and the methods of it together. And because of the use of access specifiers, the data can be protected. These members can be protected from outside interference. So this is allows the data hiding and provide much better protection of data. So this whole thing, this class encapsulates all the data members and the methods together into it. Okay, it acts as a wrapper. So there are mainly 4 types of access specifiers. One is public, private, default, and protected. So these are the 4 access specifiers available in Java. If you define it as public, if any method or any variable is defined as public, then it can be accessed by everyone around it. Like, it is open to all. Protected can be used only by those classes which has inherited from a parent class. Let's say we have a class A, and from class A, another new class B is being inherited. So this B can access all the protected members of the class A and also the public members. If you define any data as private, any member or method, any member as private, then that cannot be accessed by any other class. It can be used only by itself. And the default access specifier is used when you, it can be used within a package. So all the default members can be used within a package of classes. Next feature is inheritance. As in real life, we have the same feature of having from the parent, the features of the parent being inherited to the child. The same way, we can have a parent class and a child class. So whatever features are available in the parent class can be used by the child class. So the inheritance is the process of acquiring properties and behavior of one class to another class. So the properties and behavior of the parent class can be acquired into the child class. So here, if we can consider the person as a parent class. That person will have its own name and designation. Let's say he is having its own name and designation, and he is able to eat, walk, and run. Okay, learn, walk, and eat. So these 2 are the data members and instance variables, and these are the member methods of the class person. Now from this class, 3 classes are being generated: programmer, dancer, and singer. So this programmer will be able to use the properties of the parent class. So the name and designation will be inherited to the child class. So every child class which is derived from that will be able to get the name and designation feature, and each child class will have its own feature. So each child class will have its own company name. Let's say if he is a programmer, he'll have his company name. Then if he is a dancer, he'll have there may be a group name, and if it is a singer, he has a band name and its own. So this is the instance variable of this child class programmer, and coding is the method of a child class programmer. So the company name and coding are the features of the child class, exclusive features of child class, but the features of name, designation, learn, walk, and eat are obtained from the parent class. So the parent class is also called as base class or super class, and the child class is called as the subclass or derived class. Okay, the child class is called as subclass or derived class. Next feature is polymorphism. Now, a polymorphism is the ability of a program or ability of an object to exist in more than one form. Okay, so there are 2 types of polymorphism in Java. They are overloading and overriding. Now, this overloading is also called as ad hoc polymorphism or static polymorphism, and overriding is called as pure polymorphism or dynamic binding. So what happens here is that, let's say we have a class named shape and there is a method named area in it. Now this method area from this shape, there are three other classes being inherited: circle class, triangle, and a rectangle. Now you can use the shape, the area shape. You can use the area shape. Method area to find area of the circle or triangle or rectangle. But what happens here is that the implementation of area will be different in circle and triangle and rectangle. The implementation will be different. This area is a generalized generalized method, and this the area inside the subclasses will be particular for its for finding area of that particular class. So these are the two types of polymorphism: method overloading and method overriding. Overloading is the process by which the same method will have a different implementation and different arguments. Like say here we have the method area. So this area will have the same name here. The method name will be the same, but the implementation, the line of code will be different inside circle, and also the parameter passed will be different. Say for example, to find the area we need only radius, so only one parameter is needed here. But to find the triangle we need base and height, so you need two parameters. They may be of different type. Like say here here area will be of type int, here it may be of float type. Okay, and similarly in rectangle also we need two parameters, right, length and breadth. So here area is implemented in one way, but in these three classes area is different implemented in a different way. So in for method overloading, these methods will be having the same name and signature. Same name but different signatures, that is different implementation and argument. But pure polymorphism or method overriding, it will have the same name, same arguments but different implementation. Okay, they will be having same name but different implementation. So that is overriding. So let's look into a simple Java program. So as I have told you, every Java program will be encapsulated inside a class. So this whole thing is encapsulated inside a class. And every Java program will have a main method from where the execution will be starting first. So the main method is compulsory for any Java program. So the class will have a class name. The class will be given a class name, and inside the class you will have the main method. So the main method type is, it will be always public, static, void, main. This is the syntax of main, and you have a array which to read from the command line. Now this main have again its body which is encapsulated, which is present inside the braces, and here we are displaying something. This is a simple Java program. So when we execute this, we will get the output as this is a simple Java program in the console. So now if we look into the main method, why is it defined public, static and void? The main is defined as public because it has to be made available everywhere, first thing. Then it is being called by the JVM. When the main method is being called by the JVM, if you define it as private, then it cannot be accessed outside it. So since main is being called by the JVM, it has to be always public. Then in Java, we have seen that to access any method or anything of a class, we need to create an object. We must create an object to access any member of the class. But we are using the main method before the creation of an object for that, because of which we make it as static. because since the main is being accessed before the creation of an object, it has to be defined static. Then since main doesn't have any return type, it is defined as void, and this arg string is used to take up values from the command line. When any value is being passed through command line, then we use then we pass it. Any data is being passed through command line, then it is stored into this args array. Then we define it as system.out. This system is a class available in Java, a built-in class available in Java, and the system.out indicates that you are printing something onto the console, or you are passing out something onto the output device. So here we are told to print this line. Whatever is embedded inside this double quotes is being printed onto the screen. So this is the basic simple structure of a class. So always the class will have the members. These members may be either instance variable and in the methods of the function, methods of the class, and the methods. Then after creating the class, if you want to use it, you may have to create an object for that. But in our example, we are just using a main method. We don't have any other thing, so we are not creating any object for that. Now for this, the main method should be always defined as public, since it is being it has to be made available to the JVM. Then it should be defined as static, because we are not creating any object for that main method. There is no return type for the main method, hence it is void. And the string args is used to take up all the objects which is passed through the command line. And if we want to print something onto the console, we use the statement system.out.println, wherein system is a built-in class which is available in Java, and out indicates that you are passing some data onto the output device. Now let's look into one more example. Here we are we are taking up some integer variable, and then we are printing out into the console. So here, again we have the class. We have every program should be embedded inside the class. Then we have the main method, start of the main method. Now since Java is a strongly typed language, any variable used must be declared initially. So we are declaring a variable num. Then we are storing 100 into num. The value 100 is stored into num. So we'll have a memory location named num, and that num is having value 100. Then we are printing that this statement into the output. So you will get this is num 100. The plus operator is used to concatenate here. In this instance, in this case, it is acting as a concatenation operator. So this will concatenate this string and this integer, and you will get this full string. Okay. Then now we are retrieving that value num, and you are multiplying by 2 and storing that into num again. So now num value will become 200. So after num is now when then this statement will be printed. So you get the value of num is the value of num star 2 is 200. Okay. Now there are next thing we have to note here is the use of print and println. Now what does print do? Print will print that statement. Once you print that statement, the control will stay here itself. It will not go to the next line. But when you use ln, after printing this statement, the control will come and stay here into the next line to print the statement. So if So that is why we are getting the value of num star 2 is 200 here in a single line, because we are using print here. So after this is statement, this num will be printed over here. So base 200 will be printed over there. So basically the difference is that print will be println will bring the control to the next line, but print will the control will be at the end of the line, and println will bring the control to the next line. Now, if we want, now once we write the program, once the program is done, we have to compile it. So the command used for compiling is javac, and so once the Java program is compiled, it will create a bytecode. It will create the bytecode with .class extension, and this thing will be given for execution. It will be given for execution to this bytecode will be given to the execution to run the program at the time of running. So when we want to run the program, the command used is Java and file name. So it will pass this class name as command line argument to the compiler. So this is about today's class. So in today's class, we have seen about what is class, feature, class, then and objects, features of Java, or features or buzzwords of Java, then the various features like abstraction, polymorphism, then encapsulation and encapsulation, and how to execute and how to compile and run the program. So these things we have seen in today's video. In the next video, we will look into the next details coming up. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.